D4, I like to spend a little bit of time on units. Units are very important in science, and the metric system, which is used by a professional scientist, basically uses meters and kilograms. So let's make a little chart here. The physical quantity, say, is distance. We would use X as a symbol. And there is no formula here. We'll leave a space in case there's a formula. And then we would simply say this would be meters, M for meters. Then T, which is time, it would be S for seconds. And M for mass would be the kilogram. So this would be the big three. And when I taught my classes in freshman physics, the first semester, we don't do charge, we don't do electricity. That's the second semester. I can derive all physical quantities using these three, except for temperature. May be a problem there with the Kelvin, but even there, you can think of temperature as kinetic energy of particles, and you can get a lot of mileage, my point is, with these three basic ones. In the metric system, there's something like 7 basic ones, but these three will serve our purpose for our course. Then the velocity is an example of one that's derived. In other words, this would be the derivative in one dimension here, the derivative of x with respect to time. This would be your velocity, and that would be then meters per second. And then for acceleration, you would have the derivative of the velocity with respect to time, and that would be meters per second, or meters per second squared. And we just looked at force. Force, since F equals ma, there's a formula for that. We have another quantity here where we would have, say, kilograms for the mass times meters per second squared. And we named this combination after Newton and call that a Newton. Now, when we write out Newton in this form, we use lowercase. So if you were to say like 5 newtons, 6 newtons, lowercase. So this is a short introduction to units, and it's very important to consider units, to keep units always in mind.